Hello, everybody, and welcome to my proving grounds. We are having a new session of informal IT, and we're going to try a few things different here and there. First, let's go with this. And as you can see, I'm messing around here, making some changes, and what can I say? I got some projects that I want to do, but I got a couple of things on my mind. And what's the best way to go about this? Well, first, let me refresh this. Okay. I want to talk about logic analyzers and firmware analysis. Now, where did this come from? Primarily, I was looking up some tools. Tools that you'll do either in technical support, uh, some kind of IT engineering, cybersecurity. Well, this is the topic that I went with. And the first topic, we're going to go with logic analyzers. This is basically an electronic instrument that captures and displays multiple logic signals uh, from a digital system or a circuit. Uh, the way it works, it's going to convert the captured data into timing diagrams, protocol decodes. It's going to state machine traces, opcodes, things like that. To correlate source level software, or should I say, it's going to correlate the opcodes with source level software. You got different types. You have modular, and that'll consist of mainframe or chassis, and you have modules. Well, the modular one, it contains a display, like a little screen, a readout, and little controls, things that you can actually do to manipulate in order to toggle through. Then you have portable. Sometimes they're called standalone logic analyzers, and they're portable. That's great. Normally, they don't have that many options except what's already prepackaged in it. And then you got PC based. Now, these are little hardware connectors, normally through USB or Ethernet. Now, I've been looking at a few, and I've got this. Well, actually, there's two of them. These are PC based or hardware devices that work in conjunction with software on your PC. So if I put it here, this is one. And you see it's 8 channel. It's very simple, but if you look at it, it goes from 25 kilohertz all the way to 24 megahertz. Mauser. It will load at some point. As you can see, they're not that much different. I mean, you got the connectors and you hook it up. There are different softwares you can download that will actually let you use this. And that's a different rabbit hole that we're going to go through. But one of the things might want to consider when you're going through these, they're not all necessarily built the same way. There are connectorless ones, and they normally go by vendor specific names. You'll hear compression probing or soft touch or DMAX. Uh, go with what you know or with what you're comfortable. Or if you feel adventurous, just experiment. Now, going past that, as a matter of fact, you know what? I'm going to put the links on my experimental page here. Actually, I'll put the links up later. But I'll put the actual names of these devices up on the screen. Hold up, hold up, hold up. Let me just go back to this experimental page here and let me refresh that and see if it shows up. Okay. These are the two logic analyzers that I've been looking at that I showed you before. Relatively cheap. And here's a breakdown of what they are. Other things to look into aside from logic analyzers, I'm also looking at firmware analysis tools. Now, I've been looking at different places to find out about about software analysis tools, and Microsoft Learn is actually a good place to actually get some information on this. Uh, there's a link, and the topic is software composition analysis, and it's very useful, but goes a little in depth. But you may want to check it out. On the Linux side of things, there's a resource page mentioned before that has these tools named. Um, the site is Thyrisec. I'll put that link up later because right now I'm kind of in a rush. I really don't want to do hrefs and stuff like that. But I will give you a list. As a matter of fact, let me just jump down and add that here. Okay, let me just refresh this here and see if my code doesn't like just get all on top of itself. Okay, I have a lot more space here. But anyway, as far as it looks, we have like I mentioned, Microsoft Learn. It's not highlighting or anything, but you can always copy and paste it into the address bar. And this will cover the software composition analysis topic and discussion. It's not really a discussion, it's more a how to on what you got on how to go about it, at least pertaining to Windows based systems. And then you have Linux tools. You have file utility, and that's supported on both Mac and Linux. You got binwalk, same thing. Most of these are Mac and Linux. XXD and strings, both of them. You have DD, which if you're familiar with Bash, you'll see that all the time. Ghidra is actually good on both Linux and Windows. And Kimu, Quiet Emulator, is also available, but that's just strictly Linux. And it's not exactly as in depth as it goes. That's its own animal. And I'm going to have to look into that. What else do I have to add to this? Let's see. There's a firmware analysis toolkit, or if you like the acronym, FAT. It's actually available on GitHub. It's part of what you call it, the Adify OS. So if you go to github.com and you go /Adify firmware analysis toolkit, you should be able to pull that down. Or if you just want to download the entire ISO for that Linux distro, then you get all the other tools that come with it. This has not been that big of a discussion, or well, if I had more people to talk to about this, it'd probably be interesting. But right now, it's like I'm just sharing some of the things that I'm thinking about and that I'll be experimenting with. And if anybody's got any questions, feel free. Just drop me a comment, shoot me a personal message, either YouTube, LinkedIn, take a shot. If I'm talking about something that you don't agree with or that is a problem, or if I'm wrong, tell me. If I'm wrong, I'll look it up. If you don't agree with me, we agree to disagree. But all in all, I wish everybody well and keep on learning.